Welcome to Convergence. My name is Michael Doran. I'm a California attorney. Albert Einstein said, "Among the most difficult problems in all of physics is Earth's magnetic field." I believe it's the most difficult problem in all of biology. Today I want to talk about two main themes that are kind of interconnected. One has to do with the Carboniferous period, which is a period a long time ago, hundreds of millions of years ago. And then I want to talk about a late tropical storm predictor, William Gray, and how he retired to become a skeptic, and some of the things that he had to say, and how he wasn't included in the climate elite in terms of the scholarship, and how ridiculous that is, and really, frankly, how somebody like me, a lawyer, educated though, but a lawyer nonetheless, can basically hold up my middle finger to the physics-trained scientists with this subject of climate change. Okay, so let's talk about the Carboniferous. Carboniferous is interesting, and in the climate change debate, frequently used by so-called skeptics to say, well, why would we care if today CO2 levels are what they are rising, if during the Carboniferous, frankly, where most of the carbon for coal and fossil fuels comes from, why would we care if in the past it's been 8 or 10 or whatever multiple times as much carbon dioxide in the atmosphere, especially with this mechanism that we're talking about? I just went on Wiki, and there is a graph that goes back with multiple different types of science studies that try to determine what the amount of carbon dioxide in the atmosphere, and it's usually measured in parts per million by volume. And here's a typical, just right off my cell phone that I got, and you're probably not being able to read it real well, especially since it toggled off. But basically, you can see the graph going way up there, and the chart goes to 50 million years. It's up over 600 parts per million, 6,000 parts per million. Today, what we're talking, 400 or 500. And then you get into the Carboniferous. As it's coming down, you're at the 2,000 parts per million, 3,000 parts per million, basically way higher. And then when you go and you get into 200 million and 100 million years ago, you're again at 1,500 parts per million, way higher than today. And so the argument is, well, why should we care about what we're taking out of the inactive part of the biosphere and putting into the active part of the biosphere, when in the past it's been that way, and climate hasn't been that much different than today. Maybe the oceans are a little warmer. Sometimes there's even been periods of time where there was ice sheets. So the argument that so-called skeptics certainly made at the time that I belonged to many bulletin boards, and where the debate was more active, that was one of the huge arguments that you would hear over and over and over again. Well, this is what CO2 as a greenhouse gas is, a mechanism, and so I'm going to explain why it's a huge difference to talk about a electrical forcing that CO2 makes inside cloud droplets supercooling to ice, and in the context of large-scale, low-frequency electromagnetic waves caused by lightning predominantly. And it's because the shape of the land was much different than it is today. not just supercontinents like Pangaea, but the land distributed more or less up and down like an eye, with a lot of it over the South Pole. And why is that significant? Well, because 90% of lightning occurs over land, and then the predominant amount of it occurs over the tropics. So if there isn't a lot of land in the tropic, in fact, North America and Western Europe were kind of together towards the tropic during the middle Carboniferous, and there wasn't much left other than those this part of the world at the middle, the middle and the Carboniferous end, and the Carboniferous, the late Devonian, or the 370 million years ago. All these periods of time, most of the land was over the South Pole, or some of it was a little bit of it was over the North Pole, but Gondwana was over the South Pole, or a lot of it was. And so this is new science, and it grows and develops, and paleontologists put together models of what they think the Earth looked like over time. And then that, I don't want to call it technology, but that information or that history that develops becomes more clear, and we start to understand it a little bit more. And then we start to pair it again with developments in the paleontology to look at rocks and to see and to infer from those rocks what carbon dioxide levels were. And then to know that most of our fossil fuels come from this period of time, we can be pretty confident that there's a higher level of carbon dioxide in the atmosphere, and what it looked like in terms of where the land was. So if you have a different mechanism than CO2 as a greenhouse gas, then the importance of the amount of electrical currents generated by lightning around the world globally starts to matter in a living system as to how much carbon dioxide that needs to be in the atmosphere to make these feedbacks work. So, bottom line, we're talking about apples and oranges. So CO2 today, taking it out of the inactive part of the biosphere and putting it into the active part of the biosphere, are two completely different things than going back in time to the Carboniferous, when the land was in a different place, there was less global electric currents being created by lightning, and therefore these fields that the CO2 acted upon clouds were totally different problem. Many of the skeptics were taking this position that CO2 as a greenhouse gas, which should have this trapping characteristic of heat, and I kind of bungled it a little bit before. I was talking about my head being a carbon molecule, and now my head is an oxygen molecule. Well, what I should just say is my head is a carbon molecule of 2 oxygen. I'm hit with a light photon. I start to move around, and that's heat. I bounce into other molecules maybe that don't have that characteristic as a greenhouse gas. And then I bump into water, and then the water warms up, and so we have this greenhouse gas effect. That's not how it works. And if it does work, it's canceled out by living Earth processes that use carbon dioxide in clouds in the context of electrical fields to cause these feedbacks. Okay, so now with that said, I want to talk a little bit about William Gray. So, back when I was debating on so I'm a lawyer, I love to argue, and I'm debating on these different bulletin boards, and I'd get on these hurricane and tropical storm bulletin boards, and I love to talk and learn about it. And frankly, I was very disappointed in our national services, just in terms of where they were with this, and a lot of it is just their education, their background, particularly the lack of understanding or practicing the mathematics that are involved with dampening systems, as opposed to chaotic math, or the math of chaos. Certainly probability is part of it. So William Gray was a forecast analyst. He worked out at Colorado State University, and he'd make these really, actually pretty cool seasonal forecasts of hurricanes, and he would use these different factors. It's really a probability math kind of a niche that he had, and he'd look at these different factors and come up with long-range forecasts of tropical storms. And it's still going on. Anybody can go online right now and go to Colorado State University, and Phil Klotzbach is the guy there now, but he's been doing that. He was kind of the protege of Dr. Gray, and for years they've been doing these forecasts. There's nothing. It's all out there in the open. There's nothing really interesting about it or hidden about it. But back in 2000, I'm going to go back to a 2001 forecast, and I'm going to talk, if you don't mind, I'm going to talk a little bit about a forecast that year that's important. It kind of got me started down this road that tropical storms are biological and electrical, and climate is biological and electrical, and CO2 is biological and electrical. And it's from this forecast that I became 100% certain that I was right. So that I've been talking about this since 2001 and arguing and discussing it, but I was certain in 2001, and with the convergence of all these different types of sciences coming together, they're now confirming different things, overlapping proof of what CO2's role is in climate. So in 2001, and let me also lay a little bit of groundwork. When you have a feedback system, you have to have information. And what I mean by, and this is a very common physics term. So for instance, when you talk about light from a star going into a black hole, there's no more information. Unless, of course, now there's a theory that dark matter comes from black holes, and it's like taking a small rope and whipping it, and then it hits a giant rope, and then it comes back with a lower frequency. And that dark matter is just really incredibly low frequency light, and that's why it has mass, and it's the missing mass in the universe. But anyway, so you have to have information. You have to have a way of saying that this thing here is connected to that, so that I can cause a feedback over here to do this. All right, that's just a generalization, but when you're talking about a thunderstorm in the middle of the intertropical convergence zone in Africa, or basically where there's a lot of thunderstorms in the tropics in Africa, and it turns out that those thunderstorms 6 months later are predictive of a tropical storm in the Atlantic. That's amazing, because so you're talking about an event where there's daytime heating and instability in clouds, and then there's daytime cooling, or as you go into the evening, the clouds start to cool, and then there's instability, and that instability turns into a thunderstorm, and the thunderstorm is over in 20 minutes. So now you're telling me that the rainfall from a thunderstorm in Africa will tell me whether 6 months or not later there is a tropical storm in the Atlantic? I mean, wow. How could they possibly give information to each other to cause that connection to be correlated, and actually then how was it caused? What's causing the thunderstorms to come over here and cause the tropical storm? Same thing with the QBO. I mean, I could get into all these different factors, but from 1950 to 1990, Dr. Gray was looking at these factors for his probabilistic study of hurricanes, and he would always back study them. He'd say, "Oh, what did we actually have? How many hurricanes did we actually have, and how did our factors that we use perform?" And if they continued to perform, he'd use them and use them to a certain way, and if they didn't, he'd throw them out. And it's amazing, first of all, that he was able to, that they're actually related to each other. Now, one of the things that I'm getting ahead of myself. So, in 2001, in December, Dr. Gray's forecast came out, and with it coming out, it had something very unusual. Certainly, he was starting to be political there at that time with a little cartoon. And again, you can go right on the Colorado State University website and pull this forecast out. So it was written by William M. Gray, Christopher Lancy, who's active hurricane researcher now, Eric Blake, and Philip Klotzbach, who's again he does the ACE, accumulated cyclonic energy calculations. I mean, it's often you'll see him online with that. And then he got some assistance, probably with some other students, and it says it's available on the World Wide Web at tropical.atmos Colorado State Edu Forecast Index.html. You know, you can just do a search, and it comes right up. William Gray, tropical storm forecast, and there's a listing of it. So this December 2001 forecast, there's a section in here where they do some weird things. They say, well, you know, we've been using this factor of this starting on page 6. We've been using these rainfall totals in Africa, West Africa, basically, the Sahel. We've been using these for decades, and they've worked, and all of a sudden they stopped. Let me say this again. I'm going to just read it. We believe the seasonal forecast must be based on methods showing significant hindcast skill in applications of the proposed scheme over decades of prior data. Hindcast skill demonstrates that future forecast skill is likely provided the atmosphere continues to behave in the future as it has in the recent past. Our initial 6 to 11 month early December seasonal hurricane forecast scheme, Gray et al. 1992, for June-November activity in the following year demonstrated hindcast skill for the period 1950 to 1990. The parameters responsible for these skillful early December hindcasts included 2 measures of the 9-month extrapolated quasi-biennial oscillation, again the QBO, and that's electrical, by the way. Winds at 30 to 50 millibards. That part of the atmosphere isn't electrical, but above it, where the ionosphere is blowing and moving, it moves that part of the atmosphere. So it's electric. And the season West African rainfall. These measures of West African rainfall are composed of 1. A 38-station August through September Western Sahel collection of standardized rainfall measures and 2 similar standardized rainfall data set for August to November within a 22 station region in the Gulf of Guinea. Okay, it even has a picture of the part of Africa looked at. And they go on to say it didn't work the last 9 years. It stopped working. And so we're not going to use it anymore. Well, getting back to information. So what happens? A thunderstorm occurs, a lot of thunderstorms, a little thunderstorm occur. They flow down the river. The water from the rainfall flows down the river, and then it flows into the area where these tropical storms, these Atlanta hurricanes, eventually form. So there's your information. Well, what's going to flow down with the water? You're going to have carbonation from detritus, you're going to have sedimentation, and you're going to have water. That points to CO2 as a mechanism. That points to CO2 as information dissolved in the oceans, flowing out to the ocean. That's information from sediments and methane hydrate levels, all these different things flowing from the rainfall. So what happened to turn these factors that were once gold into garbage? Well, dams. A number of dams were built, basically, that changed how rainfall flowed to the nearshore biosphere, and then how that biosphere interpreted what it was seeing there, what carbonation levels were, and then what tropical storms formed or didn't form. So this is how I knew. There's the Kanji Dam. That was completed in '68. And this was located in Kanji, Nigeria. It was opened in 1968. So again, the starting period of time for its data was 50. And then so we have one just about 20 years into it. You have a series of 3 dams and reservoirs built in the second half of the 20th century. The Kawa, Niger and Kebbi states, northwestern Nigeria on the Niger and Kudama rivers. The first dams were built in Kanji in 1969. Its reservoir, Kanji Lake, supported irrigation, fishing projects in the states where it lies, the western shore. I'm going to read further. This is from the Encyclopedia Britannica. I mean, you can look this up. It's just public knowledge of these dams built up and down Western Africa about this time. And the mechanism is this. The biosphere, the worst thing the biosphere could have happen to it is a snowball Earth. And to guard against that, what you need to have is heat fed back to melt the ice. And so how does the biosphere know this? Well, if you have flow from the mountains during the dry season, then that means there's ice melting in the mountains. And if there's no flow during the dry season, that means there's no snow melting in the mountains, and there's no snowball Earth. So the logic would be, the simple logic, the binary logic would be heat for snow in the mountains, feedback, cold for no snow in the mountains. And that's the basics of it. So if you have a giant massive dam being built on a river system, that means during the dry season you're going to have cold, typically bottom of the dam. You're going to have water for sure, though, flowing and released during the dry season. And the nearshore biosphere gets a much different signal from those reservoirs than if they didn't exist. And they feed back heat. They feed back, it's a totally different carbon dioxide release from surface flows than if the dams weren't there. And that's how I knew back in 1991 that I was correct, not about CO2 as a greenhouse gas, but CO2 as an agent inside clouds. Technology hadn't converged enough to where I could actually show it like I can now. And as the shows go further, I'm going to just show it to you. Okay, so let's talk a little bit more about Dr. Gray, because I think that he was following his instincts to become a skeptic, to retire from his work with the hurricane forecast, to become a skeptic, a vocal person who would talk about why the greenhouse gas theory didn't make any sense. And then I want to address what he was saying, and maybe kind of for the public to understand why he was saying, why he believed so fervently that he would retire from he was very famous as a forecaster, why he would retire from this, let Phil Klotzbach take over, and just before he died, he just talked about global warming was nonsense. It didn't make any sense. So what his argument is that, and there was different forms of it, but it basically said it's just too much information being put in, too many inputs, too many calculations to these, and he really attacked the global climate models. And he's just like, there's just too much information going into this, countless integration errors that are added, that just it's not going to make you can't be confident in the result. Now, what I'm talking about mechanism-wise is that this is a dampened system. So, like when I'm hot, I'm going to sweat, and when I'm cold, I'm going to shiver. The Earth is alive, and there's this electrical feedback mechanism that's occurring that cools the planet or heats the planet like a heat pump, and it does it electrically through the clouds, and carbon dioxide and other chemicals are part of this ongoing living Earth feedback system. And so it's one thing to be very confident about predicting what my body temperature is going to be in 20 years, if I'm assuming I'm alive. It's another thing to talk about all the different and calculate and put together all the different things that sum up to be the environment, the inputs that my body has to deal with, whether it's a cold morning or a hot sunny day, or I'm inside air conditioning, whatever the different places that my body is. It's one thing to talk about all that around me that my body is dampening. It's another thing to talk about my body temperature, which really has to do with keeping myself healthy and alive, right? So Dr. Gray had seen all these different inputs, and that's what he was doing, is looking at these different factors, and that was his job, making these forecasts in the future, and he was very careful about it. Verified his statistics and so forth, and then he saw these physicists talking about the greenhouse gas and correlating these different things, and he just saw it as loose science, and that's because it was the greenhouse gas theory. It was not this electrical mechanism, and it was not, most importantly, a biological mechanism that already took into account, or was taking into account, all the different inputs that come from space, that come from the different types of things like the moon and how it's orbiting and causing conductive pathways to change, or how Milankovitch over time, that cycle, and the relationship between the sun and the earth, and how the earth was tilted or wobbling or so forth in terms of solar input, or how much different type of solar particles were coming in. There's even been studies, for instance, that show how important cosmic rays are, that there's this 33 million year cycle